This content is on sampling, or how to choose people, get a sample of people to represent your population. So let's begin by defining population and subpopulation. So the word population refers to the group of people, animal institutions, the large group that you're interested in examining. So maybe you're interested in defining your population by where they live, for example, in the Navajo Nation or off the Navajo Nation, or maybe by their occupation, like you're interested in teachers, or you're interested in people who work with electrical wires. Maybe you're interested in one or the other, in something by gender, male, female, transgender, whatever we might have there. Or maybe you're interested in a particular age cohort, people who graduated from high school at the end of COVID-19 or something like that. So this is what you're doing. So who are you interested in? The large group. And you may narrow it down even more. Maybe you have a subpopulation, a smaller segment of the population in which you're particularly interested. So maybe you're interested in all people on the Navajo Nation, but the subpopulation might have age parameters, maybe just people aged 18 to 60, or gender parameters, female people in the Navajo Nation, or other descriptors like living in the Navajo Nation for more than 5 years. So this is, the population is the big group that you're interested in. So you need to then define your population. So define it as clearly and narrowly as possible. Avoid being too narrow. So an example of this would be if you stated that your population of interest was students taking research methods this semester. That's not a good population. It's too narrow, because that just will generalize to just that one little group of students, so it doesn't inform us about people in general who are taking research methods. You could also avoid being too broad. So an example is if someone stated that their population of interest was just students taking research methods. That would be too broad because it would include so many people all over the world who are taking research methods at a big class or at the graduate level, or it's just too broad. So maybe you might say your population of interest is students taking research methods in small, open enrollment four-year colleges. That might be better. It defines a population that could reasonably be represented by a sample at Dene College. So now we move on to samples. The word sample refers to a smaller group of people that will be in your study to represent the population. It's not possible to include every single member of the population in your study. You don't have money, you wouldn't get them all. There would just be too many challenges to getting every person, so you choose a sample. And good researchers take care with how they will select a sample of people who are part of this population and can represent the population. So in descriptive research like surveys, careful sampling methods are just essential. Otherwise, you'll run into problems with bias, which we'll talk about in the next slide. In experimental research, random sampling is still ideal, but it's less important in experimental research because you're going to use random assignment, which will help to keep true to the assumptions of your statistics. So what is random sampling? Random sampling is any sampling method that uses random selection in which all members of a population or subpopulation have an equal chance of being selected. So this is also called random selection. It reduces bias if you do this. So if every member has an equal chance of being selected, then you should be hearing from all the different voices. Someone should be representing almost every perspective. Random sample is not haphazard selection. And we'll look more at these other kinds of selection methods in a moment. Instead, you have to have careful planning in order to ensure representation, and it is not the same as random assignment. So random assignment is used after participants are selected to assign them to one or another condition. So lots of ways of random selection. You can put names in a hat, put the names of every single person in the population on pieces of paper, put them in a hat or a bowl or a jar, and then just draw out the number of names that you want. Or you could do something like a spinner. Assign each name to a number from a bingo spinner, and then use the bingo spinner to draw the names at random. Or technology. You could use a spreadsheet to randomly generate numbers that have earlier been assigned to individuals. And this way is probably the most common way for gaining a random sample. So there are a number of types of sampling. And so first, the types of ways that you can randomly sample. So simple random sampling, that's what I just described, putting names in a hat or something like that. Stratified random sampling is when you choose people at random from identified levels of a population. So imagine that you want to have an appropriate number of people who are male and an appropriate number who are female. So you want it to be 50-50. Then you might separate out the males and then randomly select from the males, and separate out the females and randomly select from the females. In cluster sampling, you would select groups instead of individuals. So imagine that you are interested in the various leadership at the Navajo Nation, and you wanted to get people from different chapter houses. So you might choose, say, put all of the chapter houses, names of the chapter houses into a hat, and then you would pull out the names of the chapter houses, and then you would select all of the people within the chapter houses that you had selected. Non-random sampling, which is not the best method, but sometimes is necessary. So convenient sampling is something we see a lot, selecting people who are available or who are willing. So for example, a lot of times on campus we see an email that comes around with a survey, hey, please respond to our survey. That's a convenient sample, and it's not the best because they're only getting the people who choose to respond. So they're not getting a representative of all of the population, especially they're not getting a representative sample of people who don't have good internet or who don't check their email. Snowball sampling. This might be a useful technique if you're exploring sort of a rare condition. So if you're interested, say, in something like teenagers who believe themselves to be transgender, well, in that case, it might be hard to reach this population. And so you might start out with, say, just a couple of teens that you happen to know who are transgender, and then you would ask them to give you contact information for some of their friends who are transgender. And then you might ask those friends to do the same thing. And so you get more and more people by taking those who knew your initial sample, and then the people who know their friends and the people who know their friends. And so that's a method that can be useful if you're exploring a condition that might be somewhat rare. And quota sampling is sampling from a population, but you stop taking people from a certain subgroup once you have enough from that group. So you might do a convenient sample, send out an email, but then as soon as you have enough, say you email to all of the colleges in the Navajo Nation, and then when you get enough from one particular college, then you just stop and you don't take any more, and you wait till you get enough from the other colleges. So when you write your methods, you'll be stipulating what sampling method you're going to use. And remember again, if you are just doing a descriptive study or a survey, these random sampling methods would be most important. They're not quite as important when you're doing an experiment. Once you've selected your sample, if you've used a randomization method especially, you can only use those who have been selected. So big no-nos, you can't substitute other individuals to participate unless they're randomly chosen. So if you, let's say you have your random sample and one of the people is not responding, you can't just say to the person who works across the hall from you, hey, would you take our survey? We need one more person. You can't do that. You have to randomly you have to select a random person. You can't just ask your friends or your family to please complete your survey so you get more results. You just have to keep seeking responses from those people who are randomly selected. You have to get the information from those people. You can't substitute in. And why is this so important? Because if you select your friends and family or people you know, then non-response bias is a risk. Those who were selected in different ways, like your friends, they might differ systematically from those who were not selected, and then you won't be getting information that represents the population well. For example, if you ask your friends and family to complete the survey, they will not represent the entire population of interest. They'll represent people who are kind of like you, but you might be missing other people, so you won't have enough information. So in experimental designs, we use random assignment, and that's different from random selection or random sampling. So in random assignment, we're going to select a sample and then use a random process to assign each person in that sample to one of the conditions in your experiment. It's really important in an experiment to randomly assign people. And that means that each person could either be in condition A or condition B. There's no pre-planning. No one can ask to be in a certain condition. So these randomization processes, how are you going to randomly assign? Well, you could use any of those strategies we just discussed, like putting bowls and putting all the names in a hat and drawing out a name and saying this is condition A, drawing out another name and saying this is condition B, using a random number generator. Any of those tools can be used just as you use them for random selection. Now, ideally, when you randomly assign people to a group, you want them to be blind. And when we use this word in science, as you know, that means that your study participants don't know what condition they're assigned to. This blindness, people not knowing what their condition they're assigned to, is very important for reducing bias. For example, if you are testing a medicine and you randomly assigned people to either get the real medicine or a fake medicine, and then you told them you're getting the real medicine or you're getting the fake medicine, it would change their results. Like if someone knows that they're getting the fake medicine, they might report less response, even if in fact they're feeling better. Double-blind means that neither the participants nor the researcher know what condition they are in. How many participants should you have? Typically, you would use a statistical tool to determine the optimal number for a particular statistical test. So for this paper, if you have an experimental design, have no fewer than 30 participants per condition. If you're doing a correlation, the more the better, but 30 is the minimum. Same for quasi-experimental. If you're just doing a descriptive design, a survey, you want to seek 50 to 100 randomly selected participants. So in summary, use random selection to choose people for your study if possible. If not, make sure and define how you're selecting your sample. We talked about random selection methods, physical methods like names drawn from a jar, or technological methods using a computerized random number generator. Use random assignment in an experiment to assign participants to one of your condition. And lastly, keep your participants blind to the condition they are assigned to, and if possible, keep the experimenter also blind to the condition each participant is assigned to.